Is everyone finished with the warm-up? I got a couple yeses in the chat. Okay, cool. Then let's start going over them, okay? So number one asks solve for x comma y using substitution, okay? Who wants to try this one? Does anyone remember how to do substitution? So the first equation.
Can I try?
Yep, sure.
Okay, so for for the first equation, there's 1x and 1y. And if you add those together, you'll get 12. And for the second equation, there's 2x and 1y, and you'll get 14. So if you subtract 12 from 14, you'll get 2, and x equals 2.
Yeah, so that would be elimination, right? So that would be like you're subtracting equations, you're using elimination to find it, which is correct, okay? Which is the correct way to do it. Do you guys understand what Matthew said? So he wrote these two equations, 2x plus y equals 14, x plus y equals 12. And when you subtract these two equations, when you subtract this equation from the top equation, you get 2 on the right-hand side, and you get x on the left-hand side. Once you find out x equals 2, what can you do to find y?
You just subtract 2 from 12.
Correct, okay? So did anyone else do this a different way? It's similar, but it's slightly different. No. Okay, Mary?
Okay, so let's use I used the first equation and I moved x to the right side of the equation, so it became y equals 12 minus x, and then I substituted 12 minus x for the y in the second equation, and then I simplified the second equation, and I got x equals 2.
Yes.
Then, yeah, I substituted x back into the first equation, and I got y equals 10. And you can substitute both answers into the second equation to check your answer.
Exactly. Okay, so that's the method that I asked you to use. That's substitution, where you're using one variable, substituting it so that you only have one equation in terms of one variable. Okay, but good job to both of you. Who wants to try graphing 3x plus 2y equals 12? Any ideas? Come on, someone help me start this problem. Draw the coordinate axes.
Yeah, so to graph it, you gotta convert this to y equals mx plus b equation.
Yeah.
And you do that by shifting the 2y to the right side and the 12 to the left, so it becomes 2y equals 3x plus 12.
3x plus 12.
Negative 2y equals 3x minus 12.
Yeah, so we can move 3x to the right-hand side and we get 2y. We subtract 3x from both sides of the equation, right? So then we get 2y equals 12 minus 3x, right? And then you rewrite that. Having a little trouble using my pen. And then you have y equals, what did you do from here?
Negative 2y.
Negative 2y?
Because you subtract 2y.
Okay, here. Let's start with 3x plus 2y. Yeah. Let's start with 3x plus 2y equals 12. Okay. Now what are you?
2y from both sides.
We'll subtract 2y from both sides. Sure. So we get 3x equals 12 minus 2y. And then
you subtract 12 from both sides.
Okay. 3x minus 12 equals 3x minus 12 equals negative 2y.
And then it becomes negative 2y equals 3x minus 12 when you divide both sides by 2.
Yes, you get negative y equals 3 over 2x minus 6. And then what do you do from here?
6 is the y-intercept point, so you plot a 6.
Yeah, so you can write it as y equals negative 3 over 2x plus 6. Okay, so you're going to start at 1, 2, 3, 4, 5, 6. And then use my mouse because my pen isn't working today. So you're going to start, let me plot the points in yellow. You're going to have 0, 6. You're going to have every 2 that it goes right, it's going to go 3 down, right? Because the slope is negative 3 over 2. And so the line is going to look like this. Did I do that correctly?
Yeah.
Okay, everyone got that? Any questions about that? Okay, cool. Now let's look at the last problem. Okay, so this problem asks you to solve for the system of equations using a different method. This method is elimination. So it's a method that Matthew used before, actually. So who wants to give this a try? It's 2x plus 2y equals 19, 3x plus 4y equals 8. Any ideas? Can you rewrite those? We'll call this one equation 1. For equation 2, we'll write 3x plus 4y equals 8. So any ideas? How can we eliminate one of the variables by adding or subtracting some multiple of one equation from the other? Any ideas? How about you, Anthony? Oh, Mary, you're raising your hand.
We can multiply equation 1 by 2. So we get 4x plus 4y equals 38. And then we can subtract the equations.
Yeah, so we'll subtract. Let's try subtracting equation 2 from equation 1, and then we'll get x equals, so we're subtracting this way, right? We're getting 4x minus 3x equals 38 minus 8. X equals 30. Did you get that? Yeah? No? Maybe? Let's try plugging that into equation 1 and see what we get. So if x equals 30, then y equals negative 41 over 2. Or something like that. Is that correct? Now let's try plugging that into equation 3. So it would be 90 minus 82 equals 8. And that is correct. Does that make sense to everyone? Does everyone see how we eliminated one of the variables? We eliminated y, right? Sound good? If you have any questions, now is the time to ask, because today we're going to be learning about a new topic. Okay, cool. Any questions about the homework, by the way? Because homework problems were pretty similar to this, and I checked the homework and most of you guys got most of them right. Okay, if there aren't any questions, then today we're going to be learning about quadratic equations, right? Last time we left off on factoring. So as I said, we learned about the distributive property where a plus b times some other number, c, you can distribute this. And when I don't put a dot or when I don't put an x, that implies multiplication. So a plus b, you put that in parentheses, multiply that by c, that's equivalent to a times c plus b times c. Does anyone not understand this? Does anyone understand this? Does everyone understand this? Yeah? Okay, so let's try this example. Okay, let's try to expand this. Oh, also, I forgot to mention that today, but we did go over it on Wednesday. A plus b times c plus c. You just expand like this. Okay, so there's a method called FOIL, where F stands for first, O stands for outer, I stands for inner. I can't write today. And L stands for last. Okay, so you're going to multiply the first elements inside each parentheses. So you're going to multiply A times C. Then you're going to multiply the outer ones. So outer would be on the outside. It'll be A and D, right? The last elements. And then you're going to have the inner from the I, right? FOIL. And then the last elements of each set of parentheses. Make sense, everyone? Any questions about that? Okay, so let's try an example. We have x plus y times y plus x plus 2 times y plus 1. Okay, so we're gonna try to FOIL this out. Multiply the first elements, then the outer elements, then the inner elements, and then the last elements, and then tell me what you guys get in terms of x and y. And I'll give you guys a minute to do this. Or when you're done, feel free to raise your hand. Okay, so did anyone get this yet? Daniel, do you want to give this one a try?
X times y plus 2 plus 3.
X times y plus what?
3.
Plus 3
I mean 2.
plus 2. Okay, remember, you're not just multiplying the first and then the last elements, okay? You're going to have to multiply every element from this set of parentheses with every element from this set of parentheses. So you're going to have to find some way to multiply all of them together. So you have 2 elements in this one, 2 elements in that one. That'll give you 4 combinations that you need to have. Okay, so let's try that again. Vincent, I think you had your hand up. Do you know how to expand this?
Multiply x by y.
Yep, x, y.
And then x by 1.
Yep, x.
And then you add 2 multiplied by y.
Yep.
And then you add 2 multiplied by 1.
Exactly. Okay, so that's how you expand something. When you're expanding a factorization. You're multiplying everything inside those parentheses. A plus b times c plus d. You're going to multiply a with c, a with d, b with c, b with d. And that's what I mean when I say FOIL. You're going to expand it out. Does that make sense to everyone? We're going to be doing some more examples, okay? So don't worry about it. Let's try to expand the following. I'll do the first one, okay? So when you have a square, when you have this little 2, that means you're squaring it. So you're multiplying a plus b by itself, okay? So a plus b, and you rewrite a plus b. You're multiplying these two, right? You're going to multiply the 2 a's. Let's do the first elements. Let me write FOIL, F-O-I-L. So for the first elements, we have a times a. That gives us a squared. A squared. And then for the second element, we have the outer elements, right? A times b. So that gives us ab. For the inner elements, it's b times a. And then for the last elements, we have b squared because it's b times b. But you have to remember that a times b is actually the same as b times a. And the reason is, if you can imagine a crate of eggs, for example, you have a eggs in each row, b eggs in each column. Now you rotate that crate over. You have b eggs in each row, a eggs in each column. The number of eggs didn't change, okay? Multiplication and addition are both commutative. That's commutative. Where when you multiply 2 numbers, it doesn't matter which number is first. 2 times 3 is equal to 3 times 2. It'll be 6, right? So a times b is equivalent to b times a. I just wanted to clarify that. So that's why when you expand this in simplest form, you get a squared plus 2ab plus b squared. And this 2ab comes from the fact that there are 2 terms of a times b. There's a times b and then there's b times a. But like I said, those are the same thing, okay? So memorize this. This is important. A plus b in parentheses squared is equal to a squared plus 2ab plus b squared. Make sense, everyone? An example of this is if b equals 1, then a plus 1 squared is a squared plus 2a plus 1. Got it, everyone? This one is going to be super important. So if you have questions about it, ask now. Let's try the following examples, okay? So now we have a minus b squared. Let's try that one. Samuel, do you want to try this? So we just did a plus b, now let's try expanding a minus b squared. Let me first write it out. You have a minus b, and another a minus b. So how do you imagine we would expand this? Any ideas? Nice haircut, by the way.
Not really. I don't really understand.
Okay. So remember, we're going to multiply the first elements inside each set of parentheses, and the outer elements, then the inner elements, then the last elements, and then we're going to add them all together, okay? So a and b are, just think of a and b as numbers. They're really just variables, okay? So they're symbols that represent numbers, but the reason why they're called variables is that their values can vary. So what's the first element in the first set of parentheses? Let's call this first, and let's call this 2, okay? So Samuel, what's the first element inside parentheses number 1? Is it a or negative b?
A.
Yeah, okay. So this is the first element. What about the first element in parentheses number 2? Same question. Is it a or negative b?
A.
Correct. How about the outer elements? In the first parentheses, it'll be a, okay, and then it'll be negative b in the second set of parentheses. Okay, so let's start with that. When you multiply the first two elements, the first element of each set of parentheses, when you multiply those two numbers together, what do you get? Would it be a times a, b times b, or a times b?
A times A.
Okay, let's write a squared, okay? Squared represents a times a. How about the outer elements?
A times B.
Yeah, okay, let's make sure to include the negative, okay? Because you have to keep in mind the sign matters. When you're multiplying, you have to keep in mind that positive times negative is equal to negative. Negative times negative is equal to positive, so on. Okay, so what do you think it'll be for the outer elements?
A times negative B.
Yeah, so let's write negative AB, okay? And then how about for the inner elements? What are the inner elements? It would be negative B and A, right? Samuel, do you see how those are the inner elements? This is a man-made thing to make factoring easier, okay? We only call it inner because they're inside. They're closer towards the middle. Like if this is the middle, for example, these two elements, negative b and a, they're closer to the middle. That's why we call them the inner elements, okay? So that's also negative ab. And then the last elements in each set of parentheses, that's just negative b times negative b. When you multiply two negative numbers, you have b squared, okay? So another important factorization you guys need to remember is a minus b in parentheses squared is equal to a squared minus 2ab plus b squared. Everyone remember that? Cool. Samuel, do you get it a little more now?
Yeah.
Okay, so let's try with let's continue with another example. And again, this is hard, okay? So don't worry if you don't get it at first, but that's why we have so many examples. Now our next example is a plus b times a minus b. Who wants to give that one a try? Anyone? A plus b times a minus b. I can do this one. So the first elements, when you multiply them, it'll be a times a, which is a squared. Then you have the outer elements. The outer element, remember, if this we think of as the middle, the outer elements are going to be further away from the middle. It'll be a and then negative b. Okay, so we're going to have negative ab for the outer elements. But for the inner elements, it's positive b times a. Remember that when you're multiplying two numbers, you have to keep in mind the sign right in front of the numbers, okay? So this will be positive ab, and the last elements will be b times negative b, which is negative b squared. But when you add these two together, you notice that ab and ab and negative ab cancel out. So you're left with a plus b times a minus b is actually equal to a squared minus b squared. And vice versa, okay? So when you have 9 times 11, for example, a is 9 and b is 11. Oops. Sorry. If you have 10 and 1, a is 10 and b is 1, right? Something like that. This is clearly 99 because you have 11 in the first parentheses times 9 in the second parentheses. That's 99, right? But another way to do it is think a squared minus b squared. But what is a? A is 10. So a squared is 100. What is b? B is 1. So b squared is 1. So that's another way that you can get 99, okay? Instead of multiplying it out by hand. Instead of adding these and multiplying it out, you can just set a is equal to 10, b is equal to 1. And that's an easier way to find out that 10 plus 1 times 10 minus 1 is equal to 99. It might not be super easy for small numbers, like 2-digit numbers, 1-digit numbers, but it will be a lot easier for, let's say, 6-digit numbers, or in the future when you're talking about decimals, more complex numbers, okay? So that was example number 3. Let's try this harder example. X plus y times 2x plus y. Anyone want to try this?
Can I try?
Sure, yeah. Go ahead.
So it's x times 2x, which is 2x squared.
Yep. So our first, yep. Our f will be 2x squared, and then, and remember,
And then it's x times y, which is xy.
yep. So that's the outer elements, and then,
there's y times 2x.
yes, which is 2xy,
Yeah, and then there's y squared.
and then you have y times y, which is y squared. Okay, so what's the final factorization? I mean expansion. Matthew?
It's 2x squared plus xy plus 2xy.
Okay, but combine the like terms. When I say the final expansion, I want you to simplify it, okay? I don't want you to give me a really complicated formula. Just give me the simplest form. Are you there?
Yeah.
2x squared plus what?
2x squared.
Which like terms can you combine? Like terms are the terms that have the same variables, okay?
Okay. 2x squared plus 2x times y.
Huh? 2xy, sure, and then?
Times.
Okay, when I say the same variables, I mean, for example, a squared and 3a squared you can add, okay? But you can't add something like a 2a, and 3b. But a squared and 2a squared, you'll know that's 3a squared. Okay, so in these four terms, which of them look alike? Do any of them look like they have like terms?
There's xy and 2xy and y squared.
That's
So I think you can like right, never mind.
okay. So who wants to tell me? Matthew, take a guess.
Y to the power of 4.
Mary, tell me which two terms can we combine?
We can combine xy and 2xy to become 3xy because they're like terms.
Exactly. So this one and this one, they look identical. Okay. They're the exact same variables. Like I said, when you have the same variables, you can add them. Just like you can't compare apples with oranges, you won't be able to, like Matthew tried, you won't be able to combine this term and this term. That's never possible. But xy and 2xy, you can compare apples to apples. You can just add them 3xy plus y squared. Okay, so this is a final factorization. Sorry, expansion of x plus y times 2x plus y. Are you guys starting to get it? No? Okay, let's try another example, but with numbers this time. Hopefully this will allow you to understand it more, okay? Okay, so this is to show that factoring or expanding does work, okay? So let's try to expand this. We'll solve it using two ways, and we'll show that they're equal, okay? One way we can do it is just, follow the rules of PEMDAS. Add these numbers first, then multiply. It's 5 times 12. That's 60, okay? So our final answer should be 60. Now let's try expanding it and see if we get the same answer. Daniel, do you want to try this? Try expanding this. 3 plus 2 times 5 plus 7.
So you mean you want me to like expand it?
Yeah.
Then it will be 3. 3 plus 10 plus 7.
3 plus 10 plus 7.
No, not. Wait.
It's okay. It's, yeah.
It's 3. 3 squared plus. No, that can work with. I'm not so sure.
So Anthony, you actually said it in the chat. Okay, so he said that you can just change this to a 5 and then use the distributive property to find that it's equal to 5 times 5 plus 5 times 7. Let's try to use it. Let's try to do it using distributive property where we have two numbers times two numbers, okay? So what will be Anthony, what will be the first two elements multiplied by each other? It'll be 15, right? 3 times 5. How about the second? How about the second step where we're multiplying the outer numbers? What will be the outer numbers? Anthony? Okay, so we're multiplying 3 times 7, that's 21. And the inner elements, that's going to be 2 times 5. Anthony, exactly, okay? Good job. 2 times 5, 10. Then 2 times 7, 14. And when you add these together, you get 15, 36, 46, and then 60. When you add these together, you get 60, okay? And that matches our answer from before, okay? So this shows that factoring does work. Do you guys understand now? Who's starting to understand? Can I see your thumbs? So thumbs up if you feel like, I get factoring. Sideways thumb if you feel like, I still need a little bit more practice. And thumbs down if you're like, sorry, what are we learning right now? Okay, cool. So I'm glad to be seeing a couple of thumbs up, a couple of sideways thumbs. I'll do this last example. Samuel, do you want to try this last example? 3x plus y times y plus 2x. Samuel? So what are the first elements in each set of parentheses? What are the outer elements? What are the inner elements? What are the last elements? Multiply them and then add each term together. Samuel, I can't hear you right now. Can you guys hear Samuel? Samuel, can you hear me? No. Okay, so let's move on to someone else because I can't seem to be hearing Samuel. Anyone else want to give it a try? Oh, I can hear you now. Samuel, I can hear you, I think. I can't. Never mind. Okay. Did someone turn on their mics just now? Who wants to try this problem? This last one. Mary?
Okay, so if we follow FOIL, first we do 3x times y, which equals 3xy.
Yep, exactly.
Then we do 3x times 2x, which is 6x squared.
Yep.
And then we do y times y, which is y squared. And lastly, y times 2x, which equals 2xy. Then we can combine this answer with 3xy, and so we get 6x squared plus 5xy plus y squared.
Exactly. Okay. So hopefully you guys are starting to get it. Oops. Let me try to erase this. Yeah, hopefully you guys are starting to get it. Okay, but now let's learn something different. It's related. It's actually very similar. But now instead of expanding, we'll be trying to go backwards. We'll be trying to go from the expansion into the factorization. I'll do the first one for you guys, okay? So remember how I said to you guys to remember that a plus b in parentheses, everything squared is equal to a squared plus 2ab plus b squared. Does everyone remember that? Okay, so hopefully everyone remembers that. Okay, so this first one is pretty easy. It follows this exact form, okay? It's x squared plus 2xy plus y squared. It's the same as a squared plus 2ab plus b squared, just with different variables. In this case, x replaces a, y replaces b. Does that make sense, everyone? So what do you guys think the factorization of this would be? Factorization is when it's in parentheses. So it would be in the form x plus y in parentheses, everything squared. Make sense? Let's try the next one. A squared plus 4a plus 4. Anyone want to try this? Give this a try. Mary?
Okay, so whenever I try to factor things like this, I look at the coefficients of a and the constant.
Yeah, exactly. Okay, so you look at the first term and the last term. Because we know that the last term is going to be, when we see a square in the last term, that gives us a clue. It looks something like y squared, right? So continue.
So since the last term is 4, and I also know that the coefficient of a in the middle is 4, then I know that it's kind of hard to explain this, but I know that if you have a plus b times c plus d, then c times d must equal what 4 represents, and c plus d must equal the coefficient 4.
Yeah.
I'm sorry, b and d, not c.
So that's right. Okay, so if we have something in the form x plus b times x plus d, okay, where x is a variable, b and d are numbers, okay, Let's try it to see if we can derive it from that. Now, the first two terms, when we expand this, we'll get x squared plus bx plus dx plus b times d. Now, we know b times d has to equal 4, okay? And we know, let's write that, b plus d has to equal 4. Did I say b times d or b plus d? Okay, so it's both. B plus d has to equal 4. And b times d also has to equal 4. And we know that from the last term. This comes from the second term. And this 4 comes from the last term. Does that make sense to everyone? So what two numbers would satisfy b and d? Just, this is where you have to guess. Mary?
Both should equal 2.
Exactly. So when b and d both equal 2, 2 plus 2 is 4, 2 times 2 is 4. Okay, so that works. So the factorization of this is actually x plus 2 times x plus 2. Okay, so let's try the next example. Jerry, do you want to give this next example a try? Okay, Jerry doesn't seem to be here. Daniel?
I don't want to.
Oh, okay, that's fine. That's fine. That's not really fine. Okay, Daniel?
Can you say that the one we're doing again?
Yeah, we're doing this one. C squared plus 6c plus 9. And to everyone who's participating, thank you so much. And to everyone who's not, you know, it's kind of just a waste of time for you, for me, and
C cubed plus 15?
C squared plus 6c plus 9.
No, I mean, could you do C cubed plus 15?
I'm sorry, what? Can you repeat that? Sorry, my audio was cutting out a little bit.
C cubed plus 15.
C cubed plus 15, like that?
Yeah.
Can I factor that? Yeah, so this is a little bit hard, okay? So something like this, you would be able to factor it, but then you would require radicals. Radicals are like when you have square roots, you have cube roots, you have fourth roots, stuff like that, okay? That's a little too advanced for now. Do you want to try this one? Daniel?
I was always thinking that one. I need to rethink because I was thinking about how to solve that thing, but it was like too weird. So now I'm gonna redo it.
Yeah, okay. This one is a little bit harder, okay? Anyone else want to try this one? C squared plus 6c plus 9.
Can I try it?
Yeah, thank you. Yes.
So need to find a number that adds together to be 6, and two numbers that when you multiply together equal to 9, and you find that it's 3 and 3.
Exactly.
So then you do c plus 3 times c plus 3.
Yeah, so this is hard at first. Sometimes you just have to guess, okay? But if you see, you know, this last number is a perfect square. For example, 9 is 3 squared, right? It's a perfect square. And then you test that and you go, hey, 2 times 3 is 6. Then it follows this form exactly. Then we know this entire thing, c squared plus 6c plus 9, that entire thing is a perfect square. So we can rewrite it as c plus 3 and the quantity squared, okay? Does that make sense to everyone? And then now for y squared minus z squared. So remember how we said a plus b times a minus b is equal to a squared minus b squared? So using that knowledge, I might have given you guys too big of a hint. Using that knowledge, who can factor y squared minus z squared? The other Daniel Wang? Are there two here?
Wait, this is me or?
Is there another Daniel Wang here?
Yeah.
Oh, hi, Daniel. Okay, so do you want to try factoring this one? Y squared minus C squared?
Uh, I don't know.
Oh, okay, that's fine. Okay. So Mary said in the chat, y plus c times y minus c. And that's exactly right, because when we have two numbers, we add them, when we multiply their sum by their difference, their sum is a plus b, their difference is a minus b, then we get the difference of squares, y squared minus c squared, okay? So y squared minus c squared is equal to y plus c, close parentheses, times y minus c. Okay, makes sense to everyone? And now for our last example, we have x squared minus 4. And keep in mind, 4 is a perfect square. 4 is 2 squared. So using that knowledge and this knowledge, it's pretty similar. They look pretty similar, right? Who wants to?
Is it x plus 2 in parentheses times x minus 2?
Exactly. Okay, so when we factor this, we find we have x squared plus 2x minus 2x. And so those 2x's cancel out, minus 4. Got it, everyone? Okay, I hope that made sense. So how does this relate to quadratic equations? One of the ways to solve quadratic equations is actually to get it in the form x squared plus 2ax plus a squared equals b squared, okay? Now this b squared and a squared, b and a are both constants. And by constants, I mean numbers like 2, 3, 4. And x is a variable that you're trying to find, okay? And the reason why once we get it in this form, it's useful and we can find what x equals is because this equation is equivalent to this equation. And when we have squares on both sides of the equation, we can take the square root on both sides, and then we'll be able to find that x plus a equals b or x plus a equals negative b. And then we'll get the two solutions, okay? So just as a fun fact, quadratic equations actually look something like this when you graph them, where this is the x-axis and this is the y-axis. It looks like a curve, okay? And it curves up on both sides or down on both sides, or sometimes they curve to the right or sometimes they curve to the left. And the significance of that is that quadratic equations can only have two roots at most. Okay, in general, when you have a polynomial, which is an equation written to some degree, x to the power of n equals 5 or something like that, you will have at most n roots. So x squared, where n is equal to 2, you'll have at most 2 roots. Roots as in solutions. So that might be too complicated for you guys right now, but hopefully you guys will know what I'm talking about by the end of Wednesday. Okay, so that's just a little preview to what we're learning on Wednesday. Okay, so once we get into this form, that's the easy part. Okay, then we can just take the square root of both sides and then find the two solutions. But how do we get it into this form? So let's try a couple of examples. Let's try a couple of examples where we're already in that form, in that completed square form, okay? So who wants to try telling me the solutions to this first equation? X plus 2 squared equals 4. Remember, we can take the square root of both sides, but we have to consider where x plus 2 equals 2 and where x plus 2 equals negative 2. Okay, I'll do this first example. When x plus 2 equals 2, we have x equals 0. But when x plus 2 equals negative 2, we have x equals negative 4. And the reason why both of these work is because when x plus 2 equals negative 2, when you square both sides, negative 2 squared is equal to 4. X plus 2 squared is equal to 4, right? So that is still satisfied. So that's why you have to take the positive and the minus negative solutions once you take the square root. So now that I've done the first example where you get 0 and negative 4 as your two solutions, let's try our next example where we have 2y plus 4 squared equals 9. Anyone want to try this? Samuel, do you want to give this one a try? Oh, I forgot that I can't hear you. Okay. How about you?
Can I try?
Matthew? Sure.
Okay, so 2y plus 4 can equal 3 or negative 3.
So we've split it into two equations, 2y plus 4 equals 3, or 2y plus 4 equals negative 3. How do we go from here? Any ideas, Matt? Matthew? Any ideas?
No.
Or does someone else? Okay, you don't have any ideas from here? You don't know how to solve for y from here?
Maybe we can like divide both sides by 2.
Look, Matt, you're solving for y, okay? How do you solve for y? You have 2y plus 4 equals 3.
Wait, why does it say?
Oh, so you minus 4 from both sides.
Yeah, exactly. Okay, I think we've learned this before when we learned about linear equations. 2y equals negative 1. Did someone else have a question? I heard someone say half of a sentence, but I didn't hear the whole thing.
So the 2y plus 4 equals 3. Why did it say 2y plus 4 equals negative 3?
Oh, okay. So the reason I had to split it up into two branches is because both of these solutions satisfy this equation. You know, this equation of 2y plus 4 squared equals 9. In fact, if we try to...
I just thought that the second one doesn't really make sense, so I just asked.
Yeah, okay. So let me try to explain why they do make sense, why the second one does make sense, okay? So it's because when you have the second equation, when 2y plus 4 equals negative 3, negative 3 squared, when we plug it back in, negative 3 squared is still equal to 9. When you square something, it only gives you the positive answer, right? When you square something, when you multiply a negative by a negative, it's positive. When you multiply a positive by positive, it's positive. So whenever you multiply a number by itself, it's always going to be non-negative. Okay, assuming it's like a number defined as like it's not imaginary or something like that. So negative 2 squared is going to be 4. It's going to be positive. 2 squared is also going to be 4. Similarly, we can set it equal to 3 and we can set it equal to negative 3 because when you square both of those, it will still give you 9. Is that starting to make more sense now? Both answers yield 9. So that's why we're able to split it up into two.
Oh, I understand.
Cool. Yes. Okay. So for quadratic equations, I just want to reiterate this. You will have, sometimes you'll have no solutions. Sometimes you'll have one solution. And remember, I talked about this before. When it only touches at one point on the graph, that's when you have one solution. When you have something equals 0, like for example, if this is a graph of x squared plus 5, right? And you have x squared plus 5 equals 0. Sometimes some quadratic equations will have 0 roots, 0 solutions. A root is a solution. Sometimes it'll have 2 roots when it intersects at 2 points. For example, x squared minus 4 equals 0. You'll have 2 solutions. We did this factoring example actually earlier. So x plus 2, x minus 2 equals 0. We'll talk about this more next time because I see that it is 4 o'clock. But some equations will have 2 solutions, some will have 1, some will have 0, okay? Does that make sense? So this is one of those examples, y equals negative 1/2 and y equals negative 7/2, that actually has multiple solutions. It has 2 solutions. And that's actually the maximum number of solutions you can have for a quadratic equation. Make sense, everyone? I see that it is